Hi everyone, a very good evening to all of you. Hi everyone, I hope I'm audible, visible. Good evening everyone. I hope we are live. आप सब बड़ी एकदम मस्त एकदम ढिंचा. Good evening Ankit. Hi MFFT YTX. Hi everyone, good evening. I hope आप सब बढ़िया. Yes, you all are fine. Super amazing. Yep. Okay, guys, so I am here again with yet another session of B2A series in which we are targeting NSEJS 2025. And what is the best part about this series? That we are going to cover our NSEJS syllabus and that too in English. So, anyone who is comfortable in English, don't understand Hindi that much, they can definitely follow this series B2A, that is Basics to Advanced series for the NSEJS preparation. Hi everyone, good evening, good evening. And this is the schedule that we follow, right? On this channel, it was earlier on another channel, that is VOS channel. Now we shifted this series to this channel, that is Vedantu Science Olympiad channel, our new channel for Science Olympiad preparation, your one-stop destination, right? So if you haven't subscribed this channel yet, be quick, guys. So there's another series, guys, which are there's another batch, I will call it. We are running on this channel absolutely free again for NSEJS 2025 aspirant, but ये होगा English में. चल रहा है ये बैच. तो अगर आप हिंदी में भी कंफर्टेबल हो, हिंदी प्लस इंग्लिश में, तो यू कैन फॉलो आकार बैच टू क्रैक NSEJS. Yes, चलो. So let's start today's session. That is the session on a very important topic जो क्वेश्चन अक्सर पूछे जाते हैं, जिस पर and one of the most important topic for NSEJS that you should definitely do, highly recommended, essential for exam topic, that is ionization energy. So in today's session, we are going to learn about to know about ionization energy and everything which is related to ionization energy that we are going to study. I hope everyone is ready. Hi Soni. Hi Manju. Are you all ready? Show me a thumbs up, guys, if you are ready. Yups. So what is ionization energy? So let's check the definition first. The minimum amount of energy required to remove the most loosely bound electron from an isolated gaseous atom is known as ionization energy. That means you have a neutral atom, an atom, right? And if you want to remove the valence electron out of that atom, you want to remove the valence electron from that atom, the electron which is in the outermost shell, which has the least force of attraction from nucleus, if you want to remove that electron from your atom, you are supposed to supply energy, you are supposed to give energy, the minimum energy to take out that electron from atom, that is known as ionization energy. Basically, you have an atom, right? Suppose I have this atom M, which is in gaseous state, right? M, which is in gaseous state. Now I want to take out an electron, that is, I want to make it M positive, and I want to take that valence electron out of it. The amount of energy that I will give to take out this electron from an atom is known as ionization energy. You are making your atom ionization energy. Now, my dear students, in this definition, we have some terms, right? Minimum amount of energy. This is kam se kam itni energy, right? Another is atom should be isolated and in gaseous state. Now, these two words and definition is highly important. Isolated atom means that atom which is not bonded to other atoms. Atom isolated, no bond with, no attraction with any other atom. Gaseous state, I hope you know, in gases atoms are far apart from each other. In gases the atoms, the particles are, they are far away from each other, so they are not affecting each other, they are not attracting or repelling each other in a sense, right? So that is why these two words in the definition, they are important. So whenever I define ionization energy of an atom for an element, we define it for isolated atom, that too in gaseous state, right? Yes. So this is ionization energy, and of course it is energy. So what will be the units of energy? Joule per atom, kilojoule per atom, kilojoule per mole, electron volt, they all are the units that we use for energy. So for ionization energy, guys, we are going to use these units, right? Yes. Suppose this is M atom in the gaseous state and you take out that electron by giving energy, that is you remove first electron from the atom and the amount of energy that you are giving is known as first ionization energy, IE1. Now again you want to take out another electron from the same, right? So your M becomes M positive. Now you want to remove one more electron from M positive, right? Now again you have to give energy. So now to take one more electron from M positive to make it M2 positive, you are supplying energy, that is second ionization energy. That means you are removing second electron from the atom, right? Now you want to take one more electron out of this atom. So from M2 positive, you are making it M3 positive by removing the third electron. And now the amount of energy that you are giving here is the third ionization energy, right? And so on, fourth, fifth, sixth. Now, my dear student, what you are supposed to know here, understand here is that all these values, they are different, of course. And successive ionization energies are always higher. Suppose to remove the first electron from an atom, the first electron from M, the first ionization energy is say X. To remove the second electron it is Y, and to remove the third electron it is Z. Keep in mind, Z will be always greater than Y, that will be always greater than X. Because as you are removing the electrons, number of electrons from an atom keeps on decreasing, but the nucleus, the nuclear charge remains same, right? So that means if the number of electrons are decreasing from an atom, but the nucleus, the nuclear charge remains the same, the hold of nucleus on each electron increases. I usually give this example. Nucleus is like a teacher which is holding the students in the class, which has control over all the students in the class. Now, teacher is same and the number of students keep on decreasing in the class. If the strength of students in the class is less, that means teacher has a better hold on every student. This is what is happening here, guys. One electron knock out from the atom. Now nucleus is still the same, but the electron decreases, right? So that means the hold of nucleus increases. Hence, now if you have to remove the second electron, you are supposed to supply more energy. So irrespective of the configuration, I am clearly telling you, irrespective of atom, irrespective of electronic configuration, always, always, always remember, successive ionization energies are always higher for an atom. Many times, in fact, almost every time when I teach this topic, usually student has this doubt, ma'am, it becomes more stable after losing one electron, or it becomes less stable. Initially, it was more stable, right? I am telling you once and for all, just make it very clear with you, doesn't matter, irrespective of the configuration, what it is becoming, what it was before losing the electron. Nothing matters. Nothing matters. For an atom, successive ionization energies are always higher. It is always difficult to remove the next electron from the atom. You are supposed to supply more energy, right? Yes. So ionization energy is the amount of energy required to remove the electron. More difficult it is to remove the electron, more energy you are supposed to give. It is give and take, right? So if it is very much difficult, that atom is not losing the electron, I don't want to lose my electron, so you have to convince the atom by giving more energy, right? So the atoms which have stable configurations, which are stable, the atoms which doesn't want to lose electrons, they have high ionization energy. You are supposed to give more energy, right? Yes, got it? So guys, please keep in mind, कोई भी atom हो भाई, कुछ भी configuration हो, successive ionization energies are always higher. IE1 will be less than IE2, IE2 will be less than IE3, IE3 will be less than IE4. It applies to all atoms of the periodic table, all elements, right? And so on. Got it, guys? Yep. Perfecto. So I hope you are clear what is the ionization energy, and irrespective of the configuration, you should know that the successive ionization energies are always higher. Is that clear, guys? Yes. So more difficult is the process of taking that electron from an atom, more is the ionization energy. If an atom doesn't want to lose the electron, that means you are supposed to give more energy. That atom has high ionization energy. Now the students who are live in this session, can you tell me from the entire periodic table, which group element should have the highest ionization energies according to you? Yes, which group elements are having the highest? Scan the entire periodic table, right? You have 18 groups, 7 period in the periodic table. Can you please tell me which group elements they doesn't want to lose electron? So their ionization energies are very high by default because they don't want to lose electrons. So you have to convince them by giving more and more and more of energy. Yes, it is noble gases. Group 18 elements, they are highly stable. Their configuration is stable. They have fully filled, right, shells. So they don't want to lose electrons. Noble gases, helium, neon, argon, krypton, xenon, radon, they all are very stable. So any element which is stable, which has a stable configuration, of course doesn't want to lose electron. So all such atoms will have more ionization energies. Got it, guys? Yes. So let me ask you one more thing. You have metals, you have non-metals. Can you please tell me out of metal and non-metals, which has more ionization energies? Metals and non-metals. Please remember whatever you study in your school about metal and non-metal. Metals are electropositive. They have tendency to lose electrons. Electropositive means they will quickly become positive ion. They will easily lose electron. That means metals have low ionization energy. It is easier to remove electron from a metal atom, right? Doesn't need much energy to take out that electron from metal ion atom. Whereas your non-metals, they are electronegative. That means they have, like, you are supposed to supply more energy to take out that electron, because non-metals have tendency to gain electron, not lose electrons. They're electronegative. They have lalach for electrons. Perfecto. Good. Now, as I told you the concept of ionization energy, can you please tell me what are the factors affecting ionization energy? क्या है ionization energy को affect करने वाले factors? First, atomic size. Ma'am, more is the size of atom. So the distance between nucleus and the valence electron increases. If atom is big, that means the hold of that nucleus on that valence electron is weak. So you can easily take out that electron. That means lesser energy is required to remove that electron. You are supposed to supply less energy and electron will be out. That means more is the atomic size, lesser is the ionization energy. So please keep in mind, atomic size is inversely proportional to ionization energy. Got it, guys? Yes. Atomic size more, ionization energy less. Perfecto. Yo. Now the next factor. What should be the next factor? Of course, nuclear charge, ma'am. If nucleus is strong, it has more charge. It will hold the electron tightly inside an atom. The effective nuclear charge per electron is more. So, ma'am, more is the nuclear charge. The hold of nucleus on electron is more. It is difficult to take out that electron. That means in case the nuclear charge is more, ionization energy is also more. Got it, guys? Yes? Done, 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 done. Yo. Perfecto. Perfecto. Okay. Next, screening effect. Now, shielding, screening. Inner electrons are saving the valence electron from nucleus. They are shielding, they are protecting. So, if they are very good in shielding, inner electrons are saving, screening, shielding the valence electron from nucleus charge. What does that mean? That means the hold of nucleus on valence electron is less. That means that electron can go out easily. So more effective is the shielding. Lesser is the ionization energy because the inner electrons, the screening, the shielding the atoms, right, from the nuclear charge. अंकित, yes बच्चे, अंकित मैम चैप्टर्स के नोट्स कहाँ पर मिलते हैं? तो चैप्टर के नोट you can make easily the quick short notes. Ankit, I will suggest rather than making the detailed notes, you can, if you're watching the session, you can quickly write in the short form, right? That you can do. Yups. In your own language, short notes banao, killer notes banao. Abhi मैंने recently have taken a session on how to make killer notes for NSEJS. Do watch that session, guys, because many times most of the students who are targeting junior science Olympiad, as the syllabus is very vast, they are spending unnecessarily time. They're in fact wasting so much of time, I will say, in making notes, right? So you need to understand what is important, how much it is important, how much time you should give to that practice or that note making process. Yups. Aditya, just watch that session, right? क्या क्या लिखना है, definition, right? Factors affecting ionization energy in your notes. What should be written? Just this: ionization energy is inversely proportional to shielding effect. Shielding you have already done. We are already done. So when you are making notes, what are the factors affecting ionization energy? Just write this expression: more shielding, lesser ionization energy. This crisp. Next, electronic configuration. You know the atoms which have half filled atomic orbitals or fully filled atomic orbitals, they are stable, right? Yes, half filled and fully filled atomic orbitals, they are stable. So of course the atom, if it has a stable configuration, common sense says it doesn't want to, spoil its configuration by losing or by gaining electrons, right? So that means if your atom is having the stable configuration, either it is half filled or fully filled, it will have more ionization energy. It is very difficult to remove the electron from such stable electronic configurations, right? So these are the main factors affecting the ionization energy. Now the trend of ionization energy. Can you please tell me the trend down the group? What should be the pattern of ionization energy along the period? What should be the pattern of ionization energy? Very important trends. See, ionization energies, it is an important topic. It has been asked in your NSEJS exam from past many years, not just NSEJS. In further stages also you need this topic particularly. And directly and indirectly, you are going to use this concept of ionization energies in many other chapters. So you better understand, you should have a good understanding of this topic, right? Yep, chalo. So this is the beautiful periodic table. So now tell me, as I move down the group, if I move down the group, what will happen? Now atomic size increases, right? Because the number of shell increases. So as we move down the group, atomic size increases. If atomic size increases, I just told you the ionization energy decreases because it is easier to remove electron from a bigger atom. Because there is a less force of attraction between nucleus and that valence electron. Duri zyada hai. Right? So keep in mind, journal trend says in general, as we move down the group, what should happen? Ideally, your ionization energies should decrease. That means sodium should have lesser ionization energy than lithium. Potassium should have lower ionization energy than sodium. Rubidium should have lower ionization energy than potassium. Right? So it should be easier to remove the electron as we move down the group. Less energy, you can take out the electron. So ionization energies decreases down the group because of increase in atomic size. Now let's check the trend as we move along the period. So if we move along the period, what is the one thing that matters the most, which is affecting the properties of element? Can you please tell me? If you are moving along the period, say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So if I'm moving along the period, in a period, what is being changed? What is the major affecting criteria that affects most of the property, the behavior of atoms or the elements along the period. So if I move along the period, atomic size remains more or less the same. Why? Because though it decreases, but doesn't decrease that much because the shell remains same. If I'm moving along the second period, lithium, beryllium, boron, they all have second shell as their valence shell, right? So in a period, as the valence shell number is same, so size is not that much changing along the period. But what is changing? As I move from lithium to beryllium, atomic number changes. That means number of protons in the nucleus changes. That means nuclear charge increasing at each step. So the number of valence shell remains same, but as we move along the period, the atomic number, or you can say the nuclear charge, is increasing. So because of increase in nuclear charge, the hold of nucleus on electron is more, of course. It is difficult to remove the electron, right? That means if I move along the period, ionization energies become more. The ionization energy increases because of increase in effective nuclear charge per electron. I hope I am clear with it. Yes, yes, these are the journal trend. So down the group, atomic number increases, atomic size increases, ionization enthalpy decreases, and which is the deciding factor out of all which decide कि down the group decrease होगा? The atomic size, which increases because of increase in number of shells. This is the dominating factor down the group because number of shells are increasing. The valence shell in lithium is second shell. Now in sodium it is third, potassium it is fourth shell, fifth shell, and so on. Right, guys? Okay, fine. Now let's move on to the next period. So this is a table, this is a graph basically, and similar graphs are given in your NCERT. If you're reading the NCERT also class 11 for periodic classification of element, so you must have seen this graph. You can see the values. So from lithium to sodium potassium energies keeps on decreasing. The value of ionization energies, they keeps on decreasing, right? Okay, now across the period, I just told you, as we move along the period, nuclear charge increases, and that is the dominating factor, guys, which decides how the ionization energy or the other property is going to change along the period, right? So as we move along the period, nuclear charge increases. That decreases the, that increases the hold of nucleus on electron, and hence the ionization energy increases. Got it? So you should know this journal trend, right? So this is, you can see, right? Lithium, beryllium, boron, carbon, hydrogen. Now you will see this graph and you'll see, ma'am, what is this random where this is not a continuous increase. There is some decreases also. It is not a continuous rising graph. Along the period, if you are moving from lithium to neon, the ionization energy should increase, right? Because increase in effective nuclear charge, as you just told us, ma'am. But after looking at this graph, there's some random variation, ma'am. First increases, decreases, increases, decreases. This is a zigzag pattern. It is being formed here. Now, what is happening here? I'm coming to that only, right? So, of course, you can see, and now we are going to study the exceptional cases. This for transition elements. If you remember my last session on atomic radius, which was indeed very important, if you missed that, you are doing a mistake because वो भी बहुत important है. If I have to pick two topics from the entire periodic classification of element, this chapter, periodic properties, is one of the highest weightage chapters in NSEJS chemistry. So if I am supposed to pick two topics from this entire chapter, which you should definitely do for NSEJS, one will be atomic radius and second will be ionization energy, right? Yes, so just make sure, guys, you are doing these periodic properties nicely for your NSEJS exam. They're indeed very important, mark my words, guys. Okay, guys, now let's move ahead. So if you attend that lecture of atomic radius, I told you an exception. What was the exception? 3D transition series, scandium, titanium, vanadium. This the first period of D block. Yes, Not in Akar, in B2A series only, Abu. B2A series. B2A series, the last lecture was on atomic radius. So from scandium to chromium, the size decreases, then it becomes almost constant and then it increases. So if size, atomic radius is not following the regular trend, first it decreases, then becomes constant and then increases, so will be the effect on the ionization energy, right? You know, ionization energies are dependent upon size. So generally first it will increase, then becomes almost same and then decreases, right? Increasing. Got it? Yes. Now let's come to the main important topic. But before that, let's chill, guys. Hydrogen. Hydrogen has one electron, right? So hydrogen has one electron. It behaves like a metal because it can lose that one electron. But it can also behave like a non-metal, like halogens. It can gain also one electron to become stable, right? So group 1 says you have NS1 configuration. You are a metal. Come on, dude. Come to group 1. Low ionization energy here. Group 17. You just need one electron to become noble gas. Take that electron and come with us, halogen. Yes. Thank you, Ankit. So this is a meme. Hydrogen is like, this is literally the situation of hydrogen. Hydrogen is still a controversial atom. Where to keep it, where to place in periodic table is still a question. Whether we should keep that hydrogen in group 1 or group 17. Right? So this is hydrogen. क्या करूं भाई? Periodic table is छोड़ दूं? Yes. Chalo, let's move ahead. So exceptional cases. Journal trend I just told you. As we move down the group, ionization energy should increase. As we move along the period, ionization energy should decrease. Got it? Yep. Chalo. Let's move ahead. Now this is the periodic table. Exceptions. So you please focus on second period elements. Focus on second period element. Lithium, beryllium. The second, lithium, beryllium, boron, carbon, hydrogen, oxygen, fluorine, neon. So ideally, as we move along the period, ionization energy should increase, right? I just told you. What is happening? Let me write lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and of course neon will be having the maximum because it is a noble gas, right? Now this is second period element. Second period element. Let's check, guys. Now ideally, what is the expected order? The ionization energy should increase, but there's a twist in the story. What is the twist? Beryllium. What is the configuration of beryllium? 1s2, 2s2. Stable configuration, fully filled. So this is a stable configuration. Nitrogen is again stable configuration, 2s2, 2p3, half filled configuration, stable. So the atoms with stable configuration, they doesn't want to lose electrons, right? So they have high ionization energies. You have to give a lot of energy if you want to take out the electron from them. Got it, guys? Yes. Perfecto. Yes. Now, so lithium, then we have boron. After boron, we have beryllium. You can see there is a swap. So the beryllium has more ionization energy than boron. This is an exceptional case. Why? Because beryllium has stable configuration. Then we have the normal order ahead. Beryllium, then we have carbon, then we have oxygen. Again, there is a change in the order. Nitrogen has more ionization energy than oxygen. Why? Again, because nitrogen is stable because of half-filled configuration. And then we have fluorine. So you can see the trend. There is a change. Here is a change. Right? So as I move along the period, ideally what should happen? There should be increase in ionization energy. But This is not happening here because your beryllium, your nitrogen is having the stable configuration. And I just told you the atoms which are stable, they doesn't want to lose electron or gain electron. They have a stable configuration. Why would they will lose or gain electron, right? Yeah. Now let's see the third period. In the periodic table below lithium, we have sodium. So same happen with sodium. Then we have aluminium, then magnesium. Again same. Silicon. This is sulfur. This we have phosphorus and this we have chlorine. Again you can see the difference here. Again same because magnesium has stable configuration. क्या है configuration? Phosphorus is also half filled. So just like we have in second period, we have similar. So the ionization energy of magnesium becomes more than aluminium because of the stable configuration. And similarly, the ionization energy of phosphorus, because it is half filled, same group as of nitrogen, it becomes more as compared to the sulfur. So there is a swapping of the exchanging of the position. So this is the exceptional case you should keep in mind, guys. So please see the data also. We have a data also. For beryllium, the ionization energy is 899 kilojoule per mole. And for boron, we have it is 801. So beryllium, why it is having more ionization energy than boron? Because of the stable configuration, right? Yep. You can see here the ionization energy of beryllium is more than that of boron. You can see the other cases here. I just told you the data is here. Nitrogen, oxygen. Nitrogen is half filled, so it has more 1402 ionization energy as compared to oxygen. Magnesium and aluminium. Magnesium has more ionization energy 737, whereas your aluminium is having 577. Voice is clear, guys? Okay, wait. Hello, hello. Is it fine? Am I audible now? Is it fine, guys? Is it fine? Am I audible clearly? So you can have a look at the data till the time. Yes. So because of the stable configuration, the ionization energy are being affected, of course. Am I audible? Quickly let me know, guys. Am I audible? Clearly, loud and clear. So you can see here the ionization energy of nitrogen is more than that of oxygen. Yep. Thank you, Ankit. Yes, I hope it is fine. Okay, now magnesium and aluminium. Again, the stable configuration of magnesium as compared to aluminium. Now you can see group number 13. Boron, aluminium, gallium, indium, thallium. As you know, as we move down the group, what should happen ideally? The ionization energy should decrease because of increase in number of sites, right? So guys, these are group 13 elements. You can have a look at these group down the group. Group 13 elements of the periodic table. And please see the values of their ionization energy. Group 13. So you can see boron, their aluminium has lower, but gallium has more ionization energy than indium, but still thallium has more ionization energy. So why this irregular trend here? Why this irregular? Why gallium has more ionization energy than aluminium? Why thallium has more ionization energy than? Now the secret lies in the periodic table itself. Let's have a look at the elements, guys, in the periodic table. Chalo check karte hain where they are. Let's have a periodic table. ये रहा हमारा periodic table. चलो, this is group 13. I told you this in the exceptions of atomic radius also, right? Yes, this is group 13. So you see, when you reach gallium, before gallium you have 3d electrons, d electrons. When you reach thallium, you have 4f lanthanides are there. So that means gallium has inner d electron. It has 3d electrons, and d electrons are poor shielders. So gallium has fourth shell as the valence shell, and the second last shell has d electrons. 3d electrons are there. but they are not good shielders, guys. Remember, d electrons, they do not shield the valence electron effectively. So those d electrons could not do the proper shielding. They could not save the valence electron of fourth shell from the nucleus. So gallium has almost same size as that of aluminium. This is the exceptional case I told you in atomic radius, and hence the gallium has more ionization energy than aluminium because of the poor screening or shielding by inner 3d electrons in gallium, right? Now come to thallium. Please see the position of thallium in the periodic table. See the position of thallium in the periodic table. So you can observe that before thallium we have lanthanides. Lanthanides has electron in 4f, and f subshell electrons, they are the poorest shielder. They cannot protect, they cannot shave the valence electron from nucleus. They are the worst shielders, poorest shielders. That means, what does that mean, guys? That means in thallium, because of the poor shielding by 4f electrons, the hold of nucleus on valence electron increases, hence the ionization energy increases, right? So I hope it is clear. 13 group, you can see the values here, right? Why gallium has more ionization energy? Because of poor shielding by 3d electron. Why thallium has more ionization energy? Because of the poor shielding by 4f electrons. Done? Yups. D electrons and F subshell electron, they are very poor shielders. So guys, this is the entire periodic table, and there is like ionization energies are also written for every element. You can see there are, variation in the trends. As we can see down the group, it is not regularly decreasing, and so is the case with the, next groups also somehow in some other groups. Yups. So guys, just take a note of it. This is, yups, same is the case. Tin and lead. Lead has more ionization energy. Same reason as thallium, because the poor shielding by 4f, right? And it was the question asked here, like, again, this is antimony and bismuth, right? But here the trend is good, gradually decreasing down the group. Now let's solve some questions. So I hope you are clear with ionization energy. What is ionization energy? Successive ionization energies are always higher. Factors affecting ionization energies, and also the exceptional cases, the journal trend. You should know it very clearly, very nicely, so that you can answer the questions. And in many other topics, we use the concept of ionization energy. So just make sure you are done with this. Okay. So the electronic configuration with the largest difference between first and second ionization energy means the energy required to remove the first electron and the energy required to remove the second electron from the same atom. The difference is maximum. Yes, please. So please check which one after losing one electron becomes stable. And if it becomes stable after losing one electron, that means it is very difficult to remove the second electron. More energy is to be given. Right? Just check the configuration. 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s1, 1s2, 2s2, 2p6, 3s2, 1s2, 2s2, 2p1. So just see which will not lose the electron easily. First electron you remove by giving some energy. Now it is very difficult to remove the next electron because it has become stable. See, 3s1. If you remove this 3s1 electron, it becomes stable. It has acquired the configuration. So I remove this first electron, and the energy required is first ionization energy, right? Now after losing the first, it becomes stable. Second, of course, will be higher, but because it is a stable configuration, more energy is required to remove. Yes, of course, the answer is B. After losing one electron, it becomes stable. So you have to give a lot of energy. Noble gas configuration is achieved to remove the second. Now the next question, we have the correct order for the ionization energy of sodium, boron, nitrogen and oxygen. Please see what is common in them. Do they belong to same group or same period? Please check it out and let me know. The order of first ionization energies. Yes, so what should be the answer, guys? It is B indeed. So I just told you nitrogen because it is half filled, it has more than oxygen. See, boron, oxygen and nitrogen, they belong to the same period. And I just told you nitrogen because it is half filled, it has more ionization energy than oxygen. Sodium is not from the same period, it is rather another period down the group. Sodium has third shell, rest of them has second shell. So more number of shells, lesser ionization energy. So sodium, because number of shell atomic size increases, ionization energy decreases. Now next question. The first ionization energy for three elements are given. So you have three elements and their values are given, right? You have to identify which are these. So first value is 1314, next is 1680, another is 2080. Basically you have to see which element should have lower energy value, which should have the more energy value. So you are provided with three values. Just see the order on the basis of the order. You have oxygen, fluorine and neon. So three values are given. So oxygen, fluorine and neon, which should have 1314 value, which should have 2080 value, which should have 1680 value. You're not supposed to know the values. It is just that you should know the trend, whether which has more, which has less energy, increasing or decreasing order. You are not supposed to remember the values. You are just supposed to know which has more ionization energy value, which has lesser ionization energy value, which requires more energy and which will require lesser energy to remove electron. Yes, so of course, 2080, the highest ionization energy should be of neon. And out of fluorine and oxygen, fluorine should have more value, right? So the first value is lowest, that should be of oxygen. Then second highest is of fluorine and the highest should be for neon. Got it? Yo, bingo, perfecto, done, 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 done. Now the next question. The ionization energy of nitrogen is more than that of oxygen. Why? Why? I just told you this exceptional case that a nitrogen has more ionization energy than oxygen. Why is so? These are the previous year NSEJS question, guys. So if you are seriously targeting NSEJS, you want to be in top 300 in India, and you should definitely practice such questions. Because nitrogen has stable configuration, half filled p orbital, stable configuration nitrogen has. Next question. The first ionization of energy definition is given. So which of the following element has the largest ionization energy? So out of all these elements, boron, carbon, hydrogen, oxygen, which should have the largest, highest ionization energy? So you can see most of the questions are based on second period elements. Lithium, beryllium, boron, carbon, hydrogen, oxygen, fluorine, right? Which one should have the highest ionization energy? Of course, the answer is nitrogen. As we move along the period, ionization energy increases. But हमने अभी देखा nitrogen because half filled है, stable है, it will have more ionization energy than oxygen, right? So guys, this is your homework question for today. Do not forget to write your answer in the comment section कि इनमें से which will have the highest ionization energy. So today we did ionization energy, and indeed it is an important topic if you want to prepare for NSEJS. Do not miss periodic classification of element because it is easy to understand, just need revision to make it strong, but it is one of the highest weighted chapters for your NSEJS Junior Science Olympiad exam, right? Yep. And if you are NSEJS aspirant, if you love science, do not forget to subscribe our channel, follow our series and our batch, right? Bye, take care, God bless you all. See you in the next week with yet another session on chemistry for NSEJS. Bye, take care, God bless you all.